I may be recording my face as well right now. That's okay. So this is our wrap-up video for Legendre polynomials. We just said that we were going to talk through the form of the differential equation, solve it using series, which would count as an example, and then talk about Legendre polynomials. And I said the reason we're doing this section is because it's good practice for series solutions, and it's just a special type of ODE that gives you some neat polynomials that could show up later in like your mathematical life. And so the specific type of differential equation we were solving was this one right here. We did it for general values n, but when you work on it, you're going to have just like this will be a number to you. And we said that we were only going to think about this type of thing when the absolute value x is less than 1, because we anchor from 0 when we do our series solution, and then we can't cross 1 because of what's in the denominator when you isolate y double prime. And so we started that solution the usual way we do series solutions. We assumed y equals an infinite series, what its derivatives would be, and then plugged everything in. It became that problem of just shifting all the series so you could combine them. We had that big mess of stuff that's equal to 0 that we can break down into 3 different relationships between coefficients. And then we went on and we said, okay, assume our unknown constants and then go ahead and plug everything in. We did a few until we started to see a pattern emerging for how the new constants show up. And then we said we could write our general solution in this way. Oh, let me correct that plus ... right there that I missed before. And then we sort of said, well, what does this mean? And we tried plugging in some random values n, and we can see that one of our solutions, either y1 or y2, just ends when you subtract n from the number that it is. And so we still have one infinite series in our solution, but the other one is this finite series. And if you make a special choice of C0 and C1, don't worry about what that number actually is, you arrive at the Legendre polynomials. And I wrote out the first 5 Legendre polynomials for you, sort of showing how they solve different types of equations. And then I said, there's some neat properties that these polynomials have. That's why they show up in the future. You don't have to worry about any of them. This last one's kind of cool that there's a recursive relationship between them, so that now that you know the first 2, 0 and 1, you could always solve however many you want. And I did that example, but told you not to pay attention if we were short on time. And so here's our wrap up. The most important thing, I don't know how to make that. There's like a block of my face that's blocking part of the screen right now. The most important thing is that you got more practice using series solutions. So what you need to do is be able to use the process that I had on that general n for any type of series. That's really why we did this. It was just a cool example for us to focus on those Legendre equations because they lead to some non-infinite solutions, which is kind of fun. And they lead you to Legendre polynomials. A lot of you won't ever see those again, but if you do, you'll be like, oh, they're also in differential equations. So this is your practice problem. To go ahead and try to solve this equation right here, 1 minus x squared y double prime minus 2xy prime plus 12y equal to 0. I know that's a Legendre polynomial, so I know you could go to this solution we found and just plug in the appropriate value n. But what I'd like you to do is do it without that formula, because really what matters here is that you can do series solutions, not that you can remember like what a Legendre equation is. And then like we usually do with these series, you can go ahead and stop for me when you got to that whatever it is equal to 0. Just practice setting up this type of problem, kind of see where you get. And we will talk about that, I don't know how to make that go, later when I see you in class. And then sort of one other thing to be thinking about is request practice problems by Wednesday. So this Thursday is going to be another one of those for us where we do a review day. And so if you request video practice problems that you want to see, I'll go ahead and work through those on Wednesday. So get them to me before Wednesday so that people have a chance to view them before class on Thursday. Technically, the review is for series, but if you still have like lingering questions about Laplace, I'd prefer to answer those than not. So please do send them in. If there's like an abundance of questions, I'll give priority to series solutions though. So that's everything. I'll talk to you later. Have a good day.